Now let's go over question number 228, summary ranges. You are given sorted unique integer array nums. You're going to be given an array that is composed of numbers. They're all going to be sorted, they're going to be unique, and they're going to be all integers. So whole numbers. Return the smallest sorted list of ranges that cover all the numbers in the array exactly. So you want to return an array that has lists of ranges that cover all the numbers in our nums array. That is, each element of nums is covered by exactly one of the ranges, and there is no integer x such that x is in one of the ranges but not in nums. Each range a, b in the list should be output as. So if the numbers are equal to each other, we're going to just output one number, and if they're not equal to each other, we're going to give a range of numbers. So a through with an arrow b. Now I think this is easier to see with an example. So let's look at example 1. We are given our array, which is again sorted, unique, and they're all integers. In order for us to have a range of number, so this one over here, we need to have a consecutive number. So what are consecutive numbers? Consecutive numbers are like 1, 2, 3, and 4. And this is not a consecutive number. So something like 1, 3, and 4. Because we don't have a 2 here. So numbers that increment by 1 are consecutive numbers. And obviously these two numbers would be consecutive, whereas this whole thing is consecutive. So let's try to see how our example works out. Well, if we were to look at two adjacent numbers, 0 and 1, we can see that those are consecutive numbers. We can see that 1 and 2 is also a consecutive number. And is 2 and 4 a consecutive number? Well, no, it's not, right? Because 2 increased by 1 is 3. And right now we have 4 over here. So that's not a consecutive number. So we're going to have our ranges 0 from 2. So we're going to add to our output 0 with an arrow 2. And then it's going to be 4 and 5. Well, 4 and 5 is a consecutive number. Is 7 also a consecutive number? Well, it's not, right? Because we're missing 6. So we're going to add 4 with an arrow 5. And we look at our last one. And last one is just standing alone. Just one number. So we just add that number. And this is our output. So if it's consecutive number, we add it to the range of numbers. If it's not a consecutive number, we just have a standalone number. Now let's look at example 2 just to get a better understanding. Now we have our numbers and we have 2. Well, are these two consecutive numbers? Well, it's not, right? So in our output, we're going to have just 0. And we look at 3 and 4. Are they consecutive? Yes. Now we look at 2 and 3. Are they consecutive? Yes. And now we look at 3 and 4. Are they consecutive? Yes. And we look at 4 and 6. Well, are they consecutive? No. So we add these ranges. So that's going to be 2 to 4. Now we look at 6. Well, is 6 and 8 a consecutive number? No, right? So we just add 6. And then it's going to be 8 and 9. Are they consecutive? Yes. So we add 8 to 9 and we get our result. So in order to solve this problem, you have to figure out whether the numbers are consecutive. If it is, you have to store the lower bound, which is 2 over here, and then the upper bound, which is 4, and then you want to add the arrow in the middle. So lower bound with an arrow with an upper bound. Otherwise, if it's not a consecutive number, you are just going to add that single number, whatever that is. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's implement our first solution, and our first solution is going to have a time and space complexity of O of n. So as we talked about before, what we're going to do for this problem is we're going to check if two adjacent numbers are consecutive. If it's not, we're going to just add that number in. If it is, we want to keep our lower bound and somehow check of our upper bound and add the range of numbers to our output. So let's try to do that. So first thing I want to do is I want to create a variable named output, and this is where we're going to store our result. And let's just return that over here now. And next I want to create two variables, one for storing lower bound and one for storing upper bound. So let's do let lower is equal to, let's set it to null because we can't set it to 0 because our lower bound might be something else. So let's do null and let's do upper. So that will be our upper bound. So here we're going to store our lower and upper bound. Now we want to be able to iterate through our range of numbers. So let's create a for loop. Okay, that's good. So we're iterating through our range of numbers, And we want to look at two adjacent numbers, right? So each time we're going to look at 0 and 1, 1 and 2, so on and so forth. Now, we have to figure out if our numbers are consecutive or not, right? So let's first handle our case when it's not a consecutive number. If it's not a consecutive number, we can just simply add the number to our output. So how do we check if our numbers are consecutive or not? Well, if the difference between the two adjacent numbers are not 1, it's not a consecutive number. So let's handle that. So if nums at index I plus 1 minus nums at index I, if this does not equal to 1, it means that it's not a consecutive number. So what we'll do is we will add that single number to our output. So that's going to be output.push, and we're going to push in our current number, and we want to convert this to a string. So let's just add an empty string, and let's try running this. And you can see that it returned some numbers, and I made a mistake here. This shouldn't be -1, it should be just nums, because we want to iterate through the whole thing. You can see that we are able to handle, well, the last three cases when we just have only one number or have an empty array. And here we're somewhat okay. We're somewhat done. Well, you can see that 5, there's 2, 5, and 7. Well, 7 is correct, but 2 and 5 is currently wrong because, well, it should have a range of 0 to 2, and it should have a range of 4 to 5. And for our second example, well, 0 seems good. Well, 4 isn't because we want to have a range of 2 to 4. Well, 6 seems good, and 8 and 9 should be 8 to 9. So this 9 should be 8 to 9 with an arrow. So let's just comment these out because we know that those are working. So let's try to fix these two cases. Well, in order to fix that, we have to consider the other case when the numbers are consecutive. So what we'll do is we will use a else statement. So this is the case when the numbers are consecutive. Now we have to check something. We have to check if we have a lower bound. If our lower bound is equal to null, we want to save the current number to our lower bound. So let's create an if statement. So if lower is equal to null, so if we don't have a value for a lower bound, you want to set our current number to lower. Okay, that looks good. And there are a few more things. And next we have to check, well, are the two pairs of numbers consecutive? If it is, if they are consecutive, we want to keep looping, right? So let's create a check for that. So if nums at I plus 2 minus nums at index I plus 1, if the difference is equal to 1, you just want to continue. And what we're doing here is we're actually trying to find our upper bound. So currently we are checking our current number with the next number, which is 0 and 1. If this is consecutive, it's going to obviously fail the first if statement and go to our else statement. Well, does it have a lower bound? If it doesn't, we're going to store that lower bound to our variable. So it's storing this 0. And then we check again. Is number at index I plus 2? Well, this is number 2 over here, right? And then nums at index I plus 1 is this 1. Well, are the difference between these two numbers 1? Well, if it is, it means that they're consecutive, right? So we haven't actually found our upper bound yet. So right now we're just simply looking for our upper bound. If this statement returns false, that means that we found our upper bound. So let's save our upper bound. So upper is going to be equal to nums at I plus 1. And after we find our upper bound, we want to add our result to our output. So that's going to be output.push. Push in lower plus we want to give an arrow and we add our upper bound. So that's going to be upper. After we add it, we want to do two things. We want to reset our lower to null because later if we keep the value of our lower bound, it's going to keep using the first number that we saved. So we want to reset it. And let's look at our example. Well, you can see that it's somewhat looking good. We have our range of numbers. So 0 to 2, we have 4 to 5, and we have 7. But you notice that we have 2 here and a 5 here. And well, that's because after we add or save our upper bound, that's at number at index I plus 1, right? So we are starting again from this number and comparing these two numbers. Well, that's not what we want, right? So what we have to do is we have to actually increment our number by 1 or our index by 1. And right now you can see that all the examples are looking good. So we were able to get rid of these single numbers. So it was 2 and 5. And again, that's because, well, we added number at index I plus 1. So after we add it, and after we add our range of numbers, we don't want to start again at 2. We want to start at the next number in line. So we want to start at 4. So we want to increment our index by 1. Now let's go over our code one by one, line by line, to get a better understanding. And for this example, let's use example 2 for our code review. So we're going to have, this is our array. Now, first thing we do is we create a variable named output. We create two variables, lower and upper, and this is where we are going to store our lower and upper bound. Now we create our loop to read through all the elements in our array. And next we check, well, are the numbers consecutive? So we look at two adjacent numbers. So right now, I is equal to 0. So we look at nums at index I, which is 0, and I plus 1, which is 2. Well, are the difference between them not equal to 1? Well, they're not, right? So what we do is we just simply add our current number to our output. And let's bring our output here. So we add our 0. So we're not going to run our else statement because our if statement evaluated true, and we go on to our next iteration. And our I is 1 now. So we're at over here. So we look at two adjacent numbers again, 2 and 3. Well, is 2 and 3 not equal to 1? Well, it's not, right? Because they are consecutive numbers. So this if statement is going to fail. So we look at our else statement. And we look at our first if statement. And is lower equal to null? Well, it is, right? So what we do is we store the current number to our lower. And our current number right now is 2. And we hit our next statement, which is this if statement, and we check our nums at index I plus 1 and nums at index I plus 2. Well, that's 3 and 4, right? Well, are the difference between those two numbers 1? If it is, it means that they're consecutive numbers. So we continue, we stop, and we don't run this whole code. And now our I is at 3. Well, we look at two adjacent numbers, 3 and 4. Well, obviously this if statement is going to fail. We look at our else statement. Well, do we have a value for lower? Well, lower is not equal to null, it's equal to 2. So this if statement fails. And we look at our next if statement. And our next if statement is going to look at 4 and 6. Are the difference between two numbers 1? Well, it's not, right? So this if statement is going to fail. And that means that our two numbers are not consecutive. So we run this whole line. Now we save our nums at index I to upper. And what's our number at index I? Well, it's 4, right? So we save 4 and we add our range of numbers. So that's going to be 2 with an arrow 4. And we have to reset our lower to null because if we were to have a value that's not null for lower, it's going to keep using this 2. And we don't want that, right? We want a new fresh range of numbers. So this is going to be null now. This is the important part. We have to increment I by 1. And if you remember, when we didn't, we had the number, I think it was 2 here and a 5 here. And obviously, we don't want that duplicate values, right? So that's why we have to add 1. So after we increment it by I, our pointer or I is going to be over here. So we compare these two numbers and we know that these are not consecutive numbers. So we just add in our 6, and then finally we just compare 8 and 9, and we just add that range and get our final result. Now let's go over another solution, and for this one the logic is going to be kind of same, but it's going to keep not the number itself but the pointers for the numbers. So for example, if you were to look at our example 2, when we have a range of numbers, or actually let's look at example 1. When we have a range of numbers, well, it's 0, 1, and 2, right? Because they are consecutive numbers. Well, we're going to have a pointer to this 0, and we're going to have a pointer to this 2, so that we just get the element at that respective pointer and then just add the range. So let's try to implement that. First thing is our output. This is where we store our result. Next is going to be, let's just return our output here first. All right, that looks good. And I'm going to create a variable named I, and this is going to keep the track of the lower bound. So that's the index of the lower bound. And let's create our for loop to iterate through all the elements in our nums array. All right, now I want to check if my numbers are consecutive. If you remember from before, what we did was we checked if they're not consecutive first, right? But here we're going to check if it's consecutive. If it's consecutive, what we do is we just keep going. So if, and I just made a mistake here, this should be J because we have duplicate indexes. So that's not going to work. Let's change it to J. All right, that looks good. If our next number, and if it's equal to our current number plus 1, it means that they're consecutive numbers, right? So if it's consecutive, what do? We just stop our loop and just continue. And now is going to be our else cause. Well, if they're not consecutive, so this should be nums. All right, that looks good. You want to check for a few things. So if I is equal to J, so if the elements are pointing to the same thing, it means that it's just one number. It's not a range of number. So if it's not a range of number, we want to just push in that number only. We just have to convert it to a string. So output that push, we get our number at index I, and let's just add an empty string to make it into a string, and it should be nums. And then now we have to check our other case when it's a range of values. So else we want to just add in the range of number. So output that push, and well, the lower bound I said that is going to be our number at index I. So let's do num at index I, and we want to add in our arrow, and that's going to be nums at index J. All right, that looks good, but you do see a problem with the solution, right? It's keeping our lower bound for all the instances, and that's not what we want. And when we did our first implementation, what we did was we reset our lower bound to null, but here we have to reset our index. So how do we do that? Well, our index is going to be the upper bound plus 1, so the element after the upper bound. And if you remember from our previous solution, after we reset our lower bound to null, we incremented our index by 1. So we need to do the same thing. So that's going to be index lower bound is going to be equal to J plus 1, because remember J is our upper bound, and we add 1 so that we avoid the duplicate numbers. And now we can see that we have our correct result. So let's just go over this code really quick. Well, the logic overall itself is the same. It just we tweaked it a little. We create a variable named I, and this is our lower bound, and you can rename this to lower bound or lower if you want. And we iterate through all the elements in our array, and J represents our upper bound. And if our current number, so nums at index I plus 1 is equal to the next number, well, that means that they're consecutive numbers, right? And if you remember from before, if it's consecutive, you want to just keep looping on to get the upper bound. If this evaluates to false, it means that we found our upper bound. And we check, we either found our upper bound or it's a single number that we have to add. And if the indexes are equal to each other, that means that it's pointing to the same thing, right? And if it's pointing to the same thing, it's just one number that you have to add. So we convert it into a string and add the number. Otherwise, what we do is we get the lower bound, so numbers at index I, we add our arrow, and we get our upper bound and add that range of number into our output. And finally, we have to reset our lower bound so that it points to the correct place, and it's going to be upper bound plus 1. So it's the number that comes after our upper bound. So for this one, our upper bound was 2, and we want next number in line to start our range. So that's our 4 over here. And finally, we return our output and get our result. If you guys find this helpful, make sure you guys like and subscribe. Thanks.